topic is green chemistry. The father of green chemistry is Paul Anastas. Green chemistry is the design of chemical products and processes that reduce or eliminate the use and or generation of hazardous substances. Green chemistry is about waste minimization at source, use of catalysts in place of reagents, using non-toxic reagents, use of renewable resources, improved atom efficiency, use of solvent free of recyclable. Why do we need green chemistry? Chemistry is undeniably a very prominent part of our daily lives. Chemical development also bring new environmental problems and harmful unexpected side effects, which result in the need for greener chemical products. A famous example is pesticide DDT. Green chemistry looks at pollution prevention on the molecular scale and is an extremely important part of chemistry. Due to the importance of chemistry in our world today and the implications it can show on our environment, the Green Chemistry program supports the invention of more environmentally friendly chemical processes which reduce or even eliminate the generation of hazardous substances. This program works very closely with the 12 principles of green chemistry. Goals of green chemistry: to reduce adverse environmental impact, try appropriate and innovative choice of material and their chemical transformation, to develop processes based on renewable rather than non-renewable raw materials, to develop processes that are less prone to obnoxious chemical release, fires and explosion, to minimize byproduct in chemical transformation by redesign of reactions and reaction sequences, to develop products that are less toxic, to develop products that degrade more rapidly in the environment than the current products, to reduce the requirements for hazardous persistent solvents and extractants in chemical processes, to improve energy efficiency by developing low temperature and low pressure processes using new catalysts, to develop efficient and reliable methods to monitor the processes for better and improved controls. Principles of green chemistry. These are the 12 principles of green chemistry: atom economy, waste reduction, benign by design, reduced toxicity, fewer ancillary, energy efficiency, renewable feedstocks, catalyst efficiency, quality control, and safety control. See, this is an example for a petroleum or coal industry, how the process takes place, how the biodegradable products are formed. See, the microbes digest carbon dioxide and water to do photosynthesis. From the photosynthesis, oxygen is released and sugar, organic acid, and starch fibers are formed. These microbe synthesis change chemical synthesis nature of mixed product. This changes into biodegradable product, that is waste, that they decompose and again come in the ecosystem. Or microbes, by decomposing enzyme, this decompose and comes into the system. Greening a chemical process. C. Feedstock. Use renewable feedstock. Maximize the amount of inputs that make it into final product. Catalysts play an activation energy and do more less. So by catalyst, using catalyst synthesis design, the minimum number of steps in reaction is required. Using energy, use less energy, conduct reaction at low temperature and pressure, and minimum medium and reagent conduction reaction in water if possible. Use safer solvent. By doing this, product and byproducts minimize waste, produce byproduct and products that are less toxic and biodegradable. Pollution prevention hierarchy. Hierarchy is what? Your first is prevention and reduction of the waste product, and second is recycling and reuse. We should produce such in byproducts and the starting reagents that can be recycled and reused, and the waste that can be that can undergo the treatments and goes into disposal. Now, sustainability. Meeting the needs of the present generation without compromising the needs of future generation is the goal. Green chemistry technologies of the invention, design and application of chemical product and processes to reduce or to eliminate the use and generation of hazardous substance and where possible utilize renewable raw materials is the means primary pollution prevention, not remediation. Use of chemistry for improved environmental performance. As human beings, we are part of the environment. The way in which we interact with our environment influence the quality of our life. Green chemistry, a tool. Green chemistry, a tool. Industrial ecology, sustainable development, the goal. Green chemistry lies at the heart of the industrial ecology. Green chemistry is called also benign chemistry or clean chemistry for sustainability. Refers to field of chemistry dealing with synthesis, the part to make chemicals, processing, the actual making of chemicals, use of chemical that reduce risk to humans and impact on the environment. Green chemistry education a key to sustain the development of new educational materials. Now, how can we deal with green chemistry at our practical life? Just we need to change our mindset and applying the concept in classrooms, laboratory, manufacture, and finally the surrounding environment. If the chemical reaction of the type A plus B, this give product and waste W. Find alternate A or B to avoid W. That means waste. Example, disinfection of water by chlorination. Chlorine oxidizes the pathogen thereby killing them but at the same time form harmful chlorinated compounds. A remedy is to use another oxidant such as O3 or supercritical water oxidation. Conclusion. Green chemistry preventing pollution, sustaining the earth. Green chemistry has come a long way since its birth in 1991, growing from a small grassroots idea into a new approach to scientifically based environmental protection. All over the world, government and industries are working with green chemists to transform the economy into a sustainable enterprise. Who knows, green chemistry may be next social moment that will set aside all the world's differences and allow for creation of an environmentally commendable civilization.